Hello everyone. In today's video we're going to be exploring how do we get the tangent of theta from the sine of theta and the cosine of theta. So we know that, say, the sine of an angle theta is the opposite over the hypotenuse of a triangle. We know that the cosine of an angle theta is the adjacent over the hypotenuse of a triangle. And we know finally that the tangent of theta is going to be the opposite over adjacent for a triangle. Now, the first instinct is that both sine theta and cosine theta have the same denominators, and on top they need the two things we need to divide by each other. So opposite over adjacent would be, if you multiply both top and bottom by 1 over the hypotenuse, it would be opposite over hypotenuse times adjacent over hypotenuse. And you can work with this fraction yourself and see how this goes back into that. But anyway, this fraction here, you replace opposite over hypotenuse with sine theta, and you replace adjacent over hypotenuse with cosine theta to get the fact, which is one of the first trigonometric identities that you'll learn. Tangent of theta is equal to sine of theta over cosine of theta. And basically you can use this almost anywhere to find the tangent of theta. If you go back to our table of special values, you'll notice that, say for example, we have sine thetas of 1 over 2, root 2 over 2, root 3 over 2, and cosine thetas of root 3 over 2, root 2 over 2, and 1 over 2. And finally, you can start viewing these tangent thetas as sine thetas over cosine thetas. So, for example, 1 over 2 over root 3 over 2 is just 1 over root 3. Root 2 over root 2 is just 1. And root 3 over 1 is, well, root 3. But then, now you kind of know where tangent theta is going to come from. Now, what I also want to explore is what this means on the unit circle. Say that you have the unit circle here, and you'll know that for any triangle you make, there's going to be the hypotenuse here, which is 1. This side's going to be the sine theta, or the y coordinate is going to be the sine theta, and the x coordinate is going to be the cosine theta. And this, of course, will be the point cos theta sine theta. And how would you find the gradient from this? Well, this kind of visualization, a sloped line with something in the x plane, in the x world, and something in the y world, this looks similar to the way you'd calculate the gradient. And of course, this is the same way you'd calculate the tangent of theta for any angle, because once you know, you'll be familiar with the fact that the gradient is rise over run. And since rise here is sine theta and run here is cosine theta, you'll get that the gradient of the hypotenuse in a unit circle for any theta is tangent of theta. And what does this mean in terms of when does tangent repeat itself? So say you have your slope here, and it's like that. There's one other triangle you could make for this slope here, and that's the triangle here, which is exactly the same shape as the first triangle, just rotated and translated a bit, or it's rotated about the origin by 180 degrees. Because when you're taking this angle of theta, you have to go all the way around from the line here, right? And you go up theta, and then you go 180 minus theta to get to 180 degrees, then you go down theta again, and you'll end up for something, you'll find out something like tangent of 180 degrees plus theta degrees is equal to the tangent of theta. And this holds true for any theta. The value of the tangent repeats itself every 180 degrees, no matter what. Now, this also means that there are some values of the tangent which are undefined. For example, if you have the vertical triangle, or the vertical triangles at theta equals 90 degrees, so just this line here, the gradient will be 1 over 0, which is undefined. And the same for this one down here. The gradient will be negative 1 over 0, which is also undefined. So one thing you can note is that at tangent theta is equal to, or rather, when theta is equal to 90, 270, 450, and so on, adding 150 or subtracting 150 each time, so it goes along this way as well, tangent theta will be undefined. And that is also an important fact to know. But anyway, I hope you found that interesting, this intuition as to why tangent of theta repeats itself every 180 degrees, and as to why tangent theta is undefined at certain values. And hopefully next time I'm going to talk to you about some of the graphs of these trigonometric functions on a plane where you have the function like sine theta, and then on the x-axis you just have the angle theta. And then I'm not going to draw what it looks like now, but you'll find out in the next video. Thank you for watching.